This talk is about HTTP though, which often comes into play a lot when you are developing for APIs. And as Cal mentioned a bunch of the HTTP methods that I'll be going over today. This talk is titled Grokking HTTP. I don't expect you to fully grok it in this by the end of this presentation, but I hope that you'll have gained an understanding of some surface level stuff and know that there's a lot more to dig into, and I'll give you links to the resources to dig into those. So here's what we're going to cover today in this talk. I'm going to go over just some basics, and then I will talk about some of my favorite tools for inspecting HTTP, and then I will do an overview of the protocol, which is a pretty high-level overview, but I'm finding more and more that web developers are really unaware of the protocol, and so when I interview developers to hire them, I'll ask questions about HTTP, and a lot of people can't answer the questions, even basic ones. So it's my hope that what you'll take away from this is that basic knowledge, and then know that there's a lot more to learn about. And then I'm only going to briefly touch on some advanced topics, really just enough to say, here are some advanced topics, go learn about them, because we will run out of time. And in fact, each of those topics that I'll point out later could have a whole talk on each one of them in itself. And then I want to give you some links that will show you a little bit about where the future direction of HTTP is going. Because believe it or not, there is future movement. So what does it mean to grok something? Well, grok is to intimately and completely share the same reality or line of thinking with another physical or conceptual entity. This comes from a book by Robert Heinlein called Stranger in a Strange Land, in which the main character, Michael Valentine, who is a human that was raised on Mars by Martians, is now brought back to Earth, and hilarity ensues, sort of, where he has to learn kind of how humans live, and the humans are learning about his concepts and his reality. And his level of reality is a lot different than humans, and it's because of this Martian concept. Really, the root of it is all about grokking something. The Martians feel like in order to understand something, you have to know it intimately, and that's what grokking means. So as I said earlier, I don't intend to help you know HTTP intimately. You have to take it out to dinner and wine and dine it. So I'm not going to do that for you, but I want to give you a surface understanding so you know that there's a lot more to it. So the basics. Based on some feedback I've been given in this talk before, I have added the next few slides. They may seem elementary to you, so I apologize for that if it seems like it's dumbed down, but it does really give us a great starting point. And that's because where do we start as web developers? We might start with a browser. And so when you have a browser that's open and you enter an address in the address bar, like benramsey.com, what's going to happen at this point is the browser is going to send a message to the server over using HTTP. And that message looks a lot like this. And we will go into deeper detail on the elements of this message in a few minutes. But this is a GET message that it sends to the server, and it's got some interesting information in there. The most important for this slide is that the host is benramsey.com, and the URI is just slash. It's the root of the domain. What happens is the server receives that, parses the request, and then it puts together the response, which it sends back to your browser, which renders it all. And your browser reads that response, and the response looks a lot like this. And so the server said, hey, that was okay. Here's some metadata about the resource you requested, and here is the actual resource you requested, which is not a page that looks like this. It's a bunch of content that looks like this, which your browser knows how to render because it can speak HTML. But HTTP wasn't really... HTML was originally written for HTTP, but HTTP is a protocol intended to transmit data of all different kinds and sorts. And that's what we'll talk about in a few minutes. Just the most common is HTML. So another thing that you're commonly familiar with is our web forms. And here's an example of a typical web form. It's a contact form that has some fields on it. And the HTML behind it looks a lot like this. You've got your form tags, and your form tags have some important information in them that tell the web browser what to do with that form when you click submit. The two pieces that I've got here just to talk about is the action, which is the URI that's going to handle the request, and then the method, which a lot of times is post, sometimes is get in a in an HTML page. When you click submit, it sends a post request, in this case, to the web server, and it bundles all of those fields that were a part of the form into that communication. Most of the time in a web page, the HTML form is treated as URL encoded data, and that's what this content type is: application/x-www-form-URL encoded. And sometimes in here you'll see that listed as well. I believe there's an attribute that you can specify the type with. But by default, this is what it'll send. And then that looks like this. It's just like a query string that gets put into the entity body, and that's what's sent with the post request, when just in a standard web form. What happens here in this particular example, which I thought was interesting because it has some redirection going on. So my company, Moontoast, is using Salesforce, Salesforce.com to handle this contact form. So what happens is it gets back this OK message, which has some HTML in it, and there's a meta tag, which the browser knows what to do with this refresh statement. So it does a redirect, and then that redirect is essentially a GET request to this really long, insane URL, and then it gets back another redirect, and so there were two redirects in here, and two redirects, and now the browser loads this page. So that's a little bit of what's going on when you are using HTML forms. So I wanted to point that out just to kind of give a starting ground to where we're going to go to next. So how did I see all of that? You know, I just showed you all of the HTTP requests that are going on behind the scenes. It's not difficult to see that. In fact, there are some tools in your browser, a lot of modern browsers have, that'll give you the ability to see that right away. Chrome has has like a network inspection tool. I think IE now has one. Firefox has Firebug, and Firefox might even bundle their own in now. And so these give you a great way to inspect the messages going back and forth, and to even see the HTTP messages. But those aren't my favorites. So my favorite tools are, I'm going to give you two of them here. One is called Charles. Charles is an HTTP proxy that essentially, when you start it up, it creates a proxy, and with a browser plugin, it will route all traffic in your browser through Charles. This can become a problem if you're using SSL, but there's ways to get around that with Charles by telling Charles what certificates to allow. But what happens is, and you can use things like Wireshark and what used to be called Ethereal to do the same thing, but Charles just makes it easier for you because it takes those messages and it specifically focuses on HTTP messages and can show it to you in a nice way. So over here on the side, you'll see that I made some requests to http://bin.org. I made a put request, and then there's all these parameters that you see in this one tab, but there's other tabs you can see. You can see the raw request. If it's JSON, it'll actually show it to you in like a tree style, because it knows how to parse the JSON. If it's ActionScript or Flash remoting, AMF, then it will actually take the binary AMF object and then show you all the data within it. And then you're able to manipulate any of that data and replay the request with the new data that you've injected into it. So I've actually used this a lot because we use Flash, and instead of trying to manipulate the Flash application and send new data, I'll just leave Charles open and reuse the same request over and over and just change the AMF data right from Charles. So this is an invaluable tool, and it can show you everything that's going on in the background. I use this for a lot of debugging, almost every day. And there is a $50 license fee, but I mean, I think it's well worth it. The next one that I think is invaluable is called HTTP-IE, or HTTP-PI. Ditch curl, use this. This is really helpful, really easy to use. HTTPIE.org, perfect for debugging and testing APIs, because you can just make the request directly from your command line. If you've got an XML file or a JSON file that you want to put or post up to the API, you can easily just, bring it in from standard in into the command line, and it's free and it requires Python. It's all written in Python, but this is extremely, extremely invaluable, and it beats the hell out of curl. All right, any questions about those two tools before I move into the meat? All right, let's talk about the protocol.
I do have a question.
Yeah.
So you said it requires Python, but you can use it other, like...
Oh, it's written in Python, so
okay.
you have to have
Okay,
Python
okay.
installed, but that's the only requirement, I think. So,
Okay.
which, if you're using a Mac or something, can be, and you're using Homebrew, there's like special instructions for getting Python and Homebrew, and that's why that's the only reason I mentioned that.
Okay.
All right, the protocol. As I demonstrate how to choke yourself in front of an audience. All right, so HTTP is a protocol, which means it just governs the communication between a client and the server. So there's certain rules, and in those rules it specifies actions or methods that you can perform against an HTTP server. And so RFC 2616 is the IETF RFC that governs HTTP. It was the current version is HTTP 1.1, and this was standardized, I think, in 1999. There were a few other versions before that that this just builds on, and it really hasn't changed since then. However, there was mention earlier of the patch method, which I'm not going over in this presentation, but I will have some links to that at the end. They are adding new methods and new functionality to HTTP, and without getting ahead of myself, because I'll talk about this at the end, they are working on revising or clarifying HTTP right now. So the methods that RFC 2616 defines are get, put, post, delete, head, options, trace, and connect. I'm going to talk about get, post, put, delete, and head today. These others I won't really cover. Options is for information. Trace and connect, you mostly would use those when dealing with proxies and stuff like that, but I've never really used them in practice, and so you probably won't either, unless you're doing something special like Keith Casey.
Is he doing something special?
I don't know. He is special.
Yeah, that's what I was waiting for. Being slow, man.
All right. I was waiting for Cal on that. It was just we talked about this earlier.
Tag team, huh?
So before I get into talking about the methods, though, I do want to define a couple terms. One is safe methods. Safe method is a method that would have no action other than retrieval. It's not going to cause any side effects on the server, and as a result of this, get and head are considered safe. They should have they shouldn't cause anything that happen on the server. When you make a GET request, the client that issues that GET request on your behalf, because you told it to make it, should be relatively certain and safe and sure that that request is not going to cause any harm on the server. This allows a user agent to represent post, put, and delete in special ways. So sometimes you've seen post request, like if you hit your back button on a browser or something and it's going to reissue that request, it might ask you if that's what you intend to do. And that's because you might not have actually taken the action to issue the post request, and this actually comes into play a lot with Flash and also on mobile browsers. There were phones that would actually prompt you if you tried to post something, but it couldn't tell whether or not you actually made that click to do it. So it would say, did you intend to do this? And I think Flash does the same thing in some cases, where it is not allowed to post to the server unless the user has some kind of actual action that they do. So get and head are safe. Now there's a problem with this though, and that's that historically we haven't really treated get as being safe. In fact, we've used it to do any number of things. The best example I can think of is like you're in an admin and you've got all these rows of records, and you've got this little delete link next to each record. And instead of that delete link posting to the server to delete something, it's just a get request to the server to delete, right? So there's my slide. It has a picture of like a particle accelerator. You can't see it, but what?
Tell the story. I think I was the one who told that story many years ago.
Oh, okay, go ahead.
I worked for a vendor. We had developed an administration system for some client, and this was in the wee days when we didn't know that it didn't matter. So we wrote we had some like web spidering software we were running. One of the guys was running it, and then another guy in another office was like, hey, like all the stuff that's in I'm in the administrator, and all the these rows are going away. He'd reload and more would be gone, and reload and more would be gone. Like, what's going on? Well, it was this spider thing, and we put in the guy who was running it was like, oh, it needs a username and password for the administrator. Well, I want to record that pattern too, so he typed it in and it deleted all this stuff in the database.
Exactly. So
that's not a good idea.
It's not a good idea. I think that another story was that I think the Google Web Accelerator was something you could install in your browser, and it would prefetch pages. It would find links on the page and prefetch them so that it was quicker to load. And if you were logged in somewhere and you had a bunch of delete links like that, it would just prefetch them for you because it's safe to do so, right? But so we've learned our lesson there. The other term that I need to define is idempotence. And this is not a sexual dysfunction. It is a mathematical term that means the side effects of n greater than 0 identical requests, and that's important, is the same as for a single request. So if I make the request once, it might have side effects on the server, but if I make it twice or 10 times or 100 times, those side effects will always be the same. The state of the server will always be left in the same state. So get, head, put, and delete share this property, and as a result of just the nature of options and trace, they're inherently idempotent as well. Post is not idempotent, and we'll talk about that in a few minutes. Now, imagine an API, and again, I have a nice picture in the background, but you can't see it. A hypermedia API, so I'm not going to say REST here because I don't want to get into everything that word might be tinged with, for books. So the next several examples are going to really kind of go through the HTTP protocol, and as an example behind that, I've envisioned this API for books, and we're going to use that as our example API for HTTP. And the reason I'm using an API is mainly just because I love APIs, and also because it's easier to see HTTP going on when you're kind of looking at an API. And I've already showed you just the basic browser interaction with HTTP. So a couple terms to define. API is an application programming interface. Hypermedia is the use of text, data, graphics, audio, and video as elements of an extended hypertext system in which all elements, and this is the really important part, are linked together. So a hypermedia document has links to other hypermedia documents, and that's a really important part of that. And then a book is a collection of sheets of paper bound together, and you might see them in some of the old libraries around. The background here had a bunch of old books lined up. You can't see them. All right, so here's what our API looks like, just for reference. And this is all I'm going to be using. /books is one resource, and /books/identifier is another resource. And then the media type that I'm using here is HOW, which is not a standard accepted anywhere yet. It's currently in draft specification, but I really like it. There are two flavors of it. One is JSON and one is XML. All of my examples will be using the JSON. So let's use this API to learn how HTTP works. So get. This is the method that you're most familiar with. This is a method that we just saw earlier. It just means that you're going to retrieve data. You're not going to delete items from the server with get. You're not going to do anything else that's going to cause side effects to happen. Now, we could talk about other implications of that, like when you issue a get request, if you have some kind of counter that would count up or whatever. That does change the state of the server. So, you know, kind of think about that a little bit. But we like to have counters because we like to have statistics. So those are things to keep in mind. Transfers a representation of the resource from the server to the client, and it is safe and idempotent. So here's an example get request of our fictional API. The first line to look at is the header line of the message, and it always has the method you're calling, the URI, and then the version of HTTP you're using. And all my examples have 1.1, but it could be 1.0, and if really old, maybe 0.9, but I've never seen anyone use 0.9. The next line, and actually the other lines are here, but they're just grayed out sufficiently so you can't see them at all. The next line is host, is the host header. And this is really important in HTTP 1.1. And that's because in HTTP 1.0, we didn't really have the concept of virtual hosts. So when you made a request against the server, it always went to the same site that was defined. 1.1 introduced the host header, which you always have to include now, or you always should include, and it tells the web server which virtual host to serve up. Except encoding, which is a way that we can tell the client, or the way that the client can tell the server, hey, I can decode any of these kinds of encoding if you want to send it to me in this way. So if you want to gzip the data and send it across the network zipped up, I can gunzip that. The accept header is useful to tell the server exactly what kind of content type we can receive. And in this case, we're telling the server we only receive application/how plus JSON. So if the server can't send that back to us, it might respond with an appropriate status code that says I can't fulfill your request, or it could just choose to send it back in whatever it wants to send it back in. It doesn't have to be bound by that, but you might not be able to parse it. And then finally, our user agent string, which just tells the server what we are. And in this case, my examples, I put all these together using HTTP IE, so that's the user agent string here. What the server will do is it will process that request and then send it back to us. And this is what that message might look like. And by the way, I don't cover this in this talk anymore, but these accept headers that I just talked about are part of content negotiation. And that's another topic that could be an entire talk on its own. But the content negotiation here is server driven. So basically I tell the server, here's something that I can accept, and the server makes a choice what representation to send back. In this case, the server chose the right representation to send back because it could fulfill that. So the first line is our header again, and it tells what version of HTTP the server is using. It tells the status code and then the status message. In this case, it's 200 OK. We'll have a date header, which is just usually the current time. The server header, which may or may not exist, or it may just be blank, or it could be anything. In this case, my server sends an X powered by PHP header. This might not be included. All right, now we're getting to something that is useful. E-tag. So the E-tag header might not be included by the server by default, but if you're building an application or an API, you might want to return one. And you might want to think about what that E-tag header would include in it. The E-tag header is a way that the server can tell the client about the state of the resource that the client has received. It's a unique identifier for the current state of the resource. This identifier can change. And this is really useful for conditional requests. So if you need to tell the server to update a document, and we'll see this in a minute, you can include the E-tag header in another HTTP header that I'll talk about, and tell the server, update this document, but only if it hasn't changed since this state. So the e-tag header is really important. And in this case, there's no defined way that the e-tag header, or that the value should be formatted. In this case, what I'm doing is I'm using an ID and an incrementer, so that if the document gets updated, this incrementer might update. And you'll see the ID in a minute. Last modified, which might give an indication of when this was last modified, so this can also be used in a conditional request. The content length, the content type, and then this is what's called the entity body. Now, you've seen this with HTML in it, but this is a JSON body, and so if you ever see anyone talking about the entity body, that's usually what that is. In this case, this is how. I'm not going to go over the how format, but I will point out the ID here, because this is the same ID that you saw in the e-tag above, with an incrementer on it, which is important in the next example. Oh, and this is Luke's and Laura's book, by the way.
It's nice plug, but I didn't pay for that.
I know. It has the correct ISBN number, so if you need to go look it up. All right. Are you working? Is that the last edition that you did, or is there a new one? You're in the middle. Okay.
Let's not talk about that.
Okay. All right. The next method I want to talk about, actually, it wasn't in the next example, it was in the next example. But the head method is really useful. It's identical to get, but it only returns the headers. So it doesn't include the entity body. So it's useful for getting details about a resource before retrieving the full representation. And in some cases, this is, if it's an image you're downloading or something and you want to kind of get an idea of how large it is before you pull it down, or the capabilities of the resource before you request it, you can do this. And in fact, if you're going to do ranged requests, which are out of the scope of this talk as well, but could have a whole talk about them, you might want to do a head request first, see whether or not it supports range requests, and then what kinds of range you can send it, like bytes or something like that, and then you can make a range request of just those bytes. So you can kind of chunk your request to get a piece of a document or an image. It is safe and idempotent, and this is what it looks like. This is identical to the GET request we just sent. The only difference is the head method, and then this is identical to the response we got back. It just doesn't have the entity. All right, post. So post means that the body content that you're sending should be accepted as a new subordinate of the resource that you're posting to. In literal terms, this means to append or annotate or paste after. It is not safe, and it's not idempotent. It's not safe because the state of the server changes every time you make this request, or usually changes. That's the intent. And it's not idempotent because you could issue an identical post request numerous times, and it might change the state in a different way each time you send that request. So it's not guaranteed to leave the server in the same state. And this is what it looks like. So in this case, in our fictional API example, we want to create a brand new book. So we're going to post a representation of the book, and in this case I'm posting the entire body of that. In the earlier example you saw, we were using URL encoded value that looked like a query string. So you can do that, or you can do something like this. I'm actually posting a JSON document to /books. So we'll go through my slides here. We're going to post to /books. We are specifying the content type we are sending to the server. And this is an indication to the server of what the type is so that it knows how to parse it. And this is what our body looks like. And this is, we want to create a new book with these details. So the server would then take that. Go ahead.
Quick question on the content type. Do you have to do anything specifically in the website to allow it to accept HAL plus JSON hypermedia, or is it just modifying the MIME type?
Well, the server has to support it, first of all.
I mean,
So yeah, you'd have to be posting to a server that you know supports that. There are various ways to figure out kind of from the server what content types it can accept. In fact, I'm trying to think. Keith, is there a header that the server can send back to, like with the head method that tells what content type it?
Which ones it knows?
Yeah.
I don't know what the exception would be.
That's what the client sends. Anyway, we can kind of look that up and try to figure that out later. But yeah, the server has to know how to parse it. If the server doesn't know how to parse it, it can send back a status code. I think 406 not acceptable. I think that's 406. And that tells the client that it couldn't accept that content type. And then the entity body of that response would probably indicate to the client what kinds of status or what kinds of content types it can accept. So the server sends back a, in this case, 201 created. Anything in the 200 series is a successful response. So there's 200, there's 201 created, there's 202 accepted, there's 204, which I'll show in a few minutes. There's 205. 204 means no content. 205 means reset. And so 201 created. Something that's interesting about created in this case. So let's just take a look at the entire thing overall because you can't see my grayed out areas. What's happening here is that we posted to books, right? And now a new resource has been created. Well, we're going to send back the resource that was created, and that's what we do here. But we're also going to tell the client where it now lives because it doesn't live at /books. We created it somewhere else. So we've got a location header here that tells the client where it now lives. And in fact, in our entity right here, we're going to tell the client where it lives too, because this is a hypermedia document. So it has links to other resources, and in this case to itself, and it tells the client where it is. The other thing that's important is we created an E tag for it, so the client can now kind of use that in subsequent requests. All right, and that's what we're going to do here. So put is used for the storage of information. Quite literally, you transfer the full representation of the resource to the server on every put request. Now with a post request, you don't really have to do that. My example showed us doing that. With a put request, that's really what's intended here. You can overload it to do different things if you want, but in general, that's what is intended here. It's not safe because it does change the state of the server, but it is idempotent. So every time you issue an identical put request, the state of the server remains the same from the first one. So we've got our put method, and we're going to put to the actual resource that we're updating. And here's where that E tag comes in handy. So here's a conditional request header, if match, and we're telling the server if the state of the resource matches this E tag, then go ahead and proceed with the operation. If it doesn't, then fail. And in that case, it could send back a 409 conflict status code. And just for the sake of pointing it out, the only thing I was changing was I was adding pub dates to the document, just so it was kind of clear that what was changing. And then the server is going to send us back a response. In this case, 200 OK is a good response because we're posting directly to the URI. We're updating that resource, and in this case, so that's 200 OK. I just wanted to point out that I did increment my E tag here, so it's the same ID of the resource, but I added +2 to it. So, yes.
The E tag checking and validation will be done in PHP release application.
Yeah, you would do that in your application layer, and the scheme that you use for your E tags, whether it's an MD5 of data, whether it's the ID with an incrementer like I'm doing, is really up to you. The thing I would caution on the MD5ing of data, though, is that if you're supporting multiple content types, and with HAL JSON or HAL XML, and you MD5 one content type, the other content type might look different, right? MD5. So that's the only. I've seen people talk about using MD5s of the content for your E tag, and that could throw things off there. So I'm not recommending a specific way to do your e-tags here. But yes, your application layer would inspect the e-tag, and you would have probably stored them in the database somewhere with maybe a history of changes, and you'd see what the current one is. All right, and that really just protects. So if someone else had updated this document in the meantime, we want to prevent me from creating a conflict. And so now it's it can tell me that there was a conflict, and now I get it back. My application might re-get it, and then I can make my change again and resubmit it. And then the last modify got updated. Now let's talk about delete. So this requests that the resource identified be removed from public access. So it doesn't necessarily mean that you have to delete it from the database, but this method means let's get rid of it so that it's no longer accessible to the public or to users of the application. It's not safe because the state of the server does change, but it is idempotent, just like put is idempotent. All right, so this is what a delete request looks like. In fact, it looks a lot like a GET request, really. There's two differences, obviously. The first one is that there's a delete method, and it's not a GET method. And I'm actually including my if match header here as well, because I want to indicate to the server that if the state of this resource has changed since I got it, then don't delete it right out, because I don't want to do that. I want to maybe look at the new changes if it changed. And so in this case, what I like to do is send back 204 no content. And really, the 200 series, like I said, means it was a success. So you could send back 200 OK, but 200 OK indicates that there needs to be a body in the response. You could send back the body of the entity of the object you deleted. You could send back a message that says, "Hey, success! Congratulations, it was deleted." Or you could just send back 204 no content. All right, so a couple questions. Why are put and delete idempotent? Because the data on the server changes, right? Right, but does anyone want to answer this before I show the answer slide? Why are they idempotent?
Because when you do it once or do it 100 times, the data is still updated the way you wanted it to be. So if it's a delete, the data's gone.
Yep, so the state remains the same for every identical request afterwards as it was for the first request. So just as Keith said, if you delete it 100 times, the state of the server doesn't change from the first one that you sent. So that's why it's
Question
idempotent.
for you. If you delete something once, you get back what, a 200, okay? So if you try to delete something that you already deleted, what should you get back? Should you get a 204 no content? Should you get a 404 item not found?
410 gone.
Okay.
Gone makes sense.
Gone makes sense, but yeah, I don't know. That's a good question. I think that's just kind of really up to what you want to do.
Because that's the only place where it might change.
Yeah.
I think a 404 would be the natural response, because if you're trying to delete something that doesn't exist, don't you want to tell them that?
Yeah, but the thing is, the state of the server hasn't changed, so it's still idempotent, regardless of whether you send back a 404 now versus 200 the first time you did it. So I think that's really just kind of up to you, how you want to do it. Send them all back. All right, and this is a question. The next question is one I love to ask on interview questions. What's the difference between post and put? The difference is really in the URI. Now, just for the sake of argument, I could have had the same URI for both of these, right? But the difference is in the meaning of that URI, of what it's supposed to do. So the RFC actually has a whole paragraph on this. It says, the fundamental difference between the post and put request is reflected in the different meaning of the request URI. The URI in a post request identifies the resource that will handle the enclosed entity, while the URI of the put request is the entity that's going to be updated. So that's really the difference. So post, the URI isn't necessarily the entity you were sending. It might create a new entity. It might not even create it. It might just do something on the server and process it, right? Whereas with a put, The URI you are specifying is the actual entity that you are putting up there. That's the big difference. All right, advanced topics, and I'm actually doing really well on time today, so I could have actually gone into some of the advanced topics, but anyway, I kind of cut this stuff out because I usually spend so much time on the other stuff that I run out of time. So these are advanced topics that I think you should know about, though. Caching, content negotiation, conditional request, and range request. Now caching, there's a cache control header, and so I would encourage you to go look that up. And I actually have a link to a great resource at the end of my slides. It's Mark Nottingham's, basically he has a whole tutorial on caching with HTTP. So I would encourage you to go read that. It's really important, or really useful information. Content negotiation, I've pointed that out a little bit here. And any accept header, there's a whole range of accept -- headers in HTTP, and any of these will help you do content negotiation. There's two types of content negotiation: server-driven negotiation and agent-driven negotiation. The server-driven negotiation is what we saw here, and that's where the client, our user agent, will indicate to the server types of content it can accept, whether it's accept language, like I can accept English or Spanish or whatever, whether it's accept, I can accept this content type or this content type. And it could string together multiple content types within the same accept header, which I didn't show. And it can tell which one it prefers over the others. There's also an accept character set, which says I can accept UTF-8 or I can accept some other character set. And so what these do is they tell the server what the client can accept, and the server then uses that information to determine what resource to send, or what representation to send back of that resource. Agent-driven negotiation, however, is where the user agent itself indicates to the server exactly what representation it wants to get back. And APIs like Twitter's API does this, where it ends the URL in .json or .xml. And so the agent itself is saying it is getting the exact resource it wants to get back. Whereas with server-driven negotiation, a different resource could be returned for the same URI, depending on the accept headers. Also, there is a response, kind of neat response called 300 multiple choices. So if the client were to make a GET request against /books, for example, or /books, 1, 2, 3, 4, and there were multiple, let's just say hypothetically, there were multiple resources that could return, or multiple representations it could return for books /1, 2, 3, 4, but the client didn't indicate any accept headers, then the server might send back a list of URLs and indicate to the client what content type they are, using some kind of format, like HTML links, or HAL-JSON, or XML, or something like that. So then the client can then look at that and either presenting it to the user to click on a link, or by intelligently picking one that it wants to pick, it could then follow those links and go and pull the right resource. Conditional request, we looked at that a little bit. Any of the if dash header requests, those are conditional. So if match, if this matches, then send it back. If last modified, or if modified since, you can send a date and say, if this has been modified since this date, then give me back a fresh copy of it. Otherwise, it might respond with 304 not modified. And then range request, I talked a little bit about that, but we didn't see an example. And that's a way that you can chunk up your request and say, I only want 1,000 bytes in this request, and then the next request I want the next 1,000, and so forth. But what I did want to point out that I think is important for everyone to know is that HTTP has a future. It's not just stuck in 1999. There's a lot of development going on these days with the HTTP BIS IETF working group. And BIS is a Latin word for again, I think. And don't quote me on that, but look it up. But basically, they have revived the working group, and it's the working group again. And so they are talking about how HTTP has been used over the last 13 years now, and they are clarifying it. And what they're producing is a whole bunch of new RFCs that will be accepted in, and they're splitting up RFC 2616 into a bunch of little RFCs. So they're actually taking the caching piece and having an RFC just for it, and the content negotiation piece and having an RFC just for it. And they hope that through doing this, they won't have this huge long RFC, but they'll have a few that are more bite-sized and more easy to understand. And they're not really changing how HTTP works, they're just kind of clarifying is their word for it. But there are a bunch of new developments going in too. And so Kyle mentioned the patch method, RFC 5789, and this will be included in the clarification of HTTP. So those are the kinds of things that are coming along. Also, though, something to keep your eye on is that they are accepting not predecessors. They're accepting successors to HTTP. So they're looking at RFCs that define HTTP 2.0, or what will become 2.0. And like an example of one that they have listed on their website is the Speedy protocol, SPDY. I think Google is spearheading that. So that's one thing that they have listed as a possible successor to HTTP 1.1. There's a whole bunch of WebDAV resources. Actually, all of these are links, and I'll have a link in just a URL in just a minute to my slides. And each one of these, if you download the slides, the PDF, you can click on any one. So this takes you to a WebDAV website. I don't really encourage the use of WebDAV, but there's a whole bunch of stuff in there, a whole bunch of methods that you might find useful, a whole bunch of status codes you might find useful. And in fact, if you're more interested in just looking at the method list and status code, these 3 links down here will show you message headers that have been accepted in other RFCs, and all method registrations that have been accepted. So that would include patch and so forth. Other useful thing is 6585, 6266 that are actually pretty new. Additional status codes, and I think well, I'm not going to say something that I'm going to be wrong at saying. Go read it. It's really useful information. So the final thing is that there's too much to Grok in too much in HTTP to fully Grok in one presentation. But I've given you a lot of resources here, and I've kind of just touched the surface, and I hope that you'll take that and it'll encourage you to go through and read more about it. And here's what I want this to do for you. I want it to really enhance your development and your debugging skills of your own applications. Whether you're developing an API or whether you're developing a dynamic website. Knowledge of HTTP and how it's working, and just knowing how to go look at Charles and figure out what headers are being set by your application is really useful information. A lot of more links to more resources. This is the caching tutorial that Mark Nottingham wrote, and a couple more RFCs that are kind of interesting to read and dry, but interesting. And then here's my blog, and here is where you can rate this talk, and also the link to the slides is on this page as well. So you have to go to the Rate My Talk to see the link to the slides. So it's a bait and switch thing, right? But thank you for your attention, and I'm open to any questions right now if you have anything. I'll go here and then to Ed.
So when you do a request that's idempotent, like the get or the head or put, it says that nothing's going to change on the server side, but you might not necessarily get the same response back based on what they were just saying. Is that correct?
Oh, okay. That's actually a good question. I would say, so let's just say it's a GET request. I would say that, well, you know what? In a GET request, it's not even really idempotent in the sense because it's safe, right? So a safe method would be idempotent just by nature, by the fact that it's not going to change the state of the server at all anyway. but it's going to retrieve data. Now on a dynamic page, that data might change. So even if it's always a 200 OK, what's in the response body might be different based on just the time that you requested it, what's going on the website, and so forth. So just the fact that the data in the response changes doesn't necessarily mean that the state of the server has changed in that kind of idempotent sense. Now with a put request, the reason that's considered idempotent is because that request is always going to have the same exact state change on the server. And so it's not necessarily that the state of the server doesn't change after you issue the request, it's just that that request always has the same state change associated with it.
So it just always says the same thing.
Yeah, exactly. So like I might make one request, like a put request that changes something, and someone else may make another put request that changes a different thing. Now the state of the server has changed differently than it was when I made my request. But when I make my put request again, the state of the server is exactly the same as it was when I made my put request before. So I hope I explained that well. Oh, Ed.
Yeah. If you want to use a hash that you can't, like let's say.
So there is the overloading post methodology.
Well, I wonder. So is that the least heinous way of doing it?
I think so. I mean, I don't see any other way of really doing it. So a lot of people recommend overloading post, and you could use an X header that says X method that tells what method you're really intending, or you could use like underscore method in the query string. And some frameworks will actually take that underscore method and translate the route to which route you intended for put or post or patch, even though the method that was sent to the server was post. So they'll do the routing for you to the correct place. And I don't know what frameworks support that, but I think a lot of modern ones do. Any other questions? All right, well, thanks. I don't know what's going on next. So I guess